Assalamu alaikum. Welcome to Mass Academy. In this video, we are discussing Physics Term 2 examination for Grade 9 Advanced. In Physics Term 2 examination, there are three parts. Part 1 and Part 2 are electronic examination. Part 3 will be paper-based exam. You need to write on the paper. In Part 1, there will be 6 simple questions. These will be multiple choice questions, and in part 2 there will be 10 questions that will be little advanced questions, that also multiple choice, and in part 3 there will be 4 questions that you need to write on the paper. All these 20 questions will carry 5 marks. Each question will carry 5 marks, and there will be 2 bonus questions, and those 2 bonus questions will also carry 5 marks each. Now we are going to discuss all 20 questions given in end of term 2 examination revision. Before we start, I would like to request you to subscribe my channel. Please subscribe this channel and we will start. Question number 1. Determine the components of a vector in Cartesian coordinate system using trigonometry. So question number 1 is from resolution of vector or resolving a vector. What's the meaning of resolving a vector? Resolving a vector means dividing a vector into x component and y component. For example, here we have this coordinate system. This is the x-axis and this is the y-axis. So here we have a vector that is not along the x-axis and not along the y-axis, but it is along or in between x and y. For example, this vector that we will represent by the letter V, and this vector makes an angle theta from the x-axis or theta from the horizontal. This x-axis is called horizontal. X-axis is the horizontal axis. Then what is the y-axis? Y-axis we will call vertical axis. So this vector V makes an angle theta from the horizontal. So this vector that we can divide into x component and y component. Why? Because this vector is in between x-axis. This vector is in between x-axis and y-axis, which means this vector has an x part and a y part. So we will divide this vector into its x part and its y part. That's called x component and y component. So this x component of this vector, how to calculate the x component? The equation to calculate x component that we will represent by Vx, the x component of the given vector, that equal to V multiplied cos theta. V multiplied cos this angle theta. So what is cos? Cos is a trigonometric operator that you can see in the calculator cos. So when you calculate, you can just press that. Then what is the value of the y component, or how y component that we will represent by Vy? The y component of this vector V, y component is along this direction, along the y-axis, that you can calculate using the equation, the given vector V multiplied sine of this angle theta. For example, so this is our y-axis and this is the x-axis, and we have a vector. We will draw a vector here. So what is the magnitude of this vector? For example, magnitude of this vector is 5 Newton. So this is a force and its magnitude is 5 Newton, and this is not along the x-axis, not along the y-axis, but it is acting in between x and y, which means it has x component and it has a y component. So this is the x component of this vector, and this force is making an angle, for example, 35 degree from the horizontal. This vector, this force, that is 5 Newton force, is making an angle 35 degree from x-axis, means this 5 Newton force is acting along this direction. It is acting at an angle 35 degree from the x-axis. So how to calculate the x component Vx? Vx of this force, that is v multiplied cos theta, that is the equation, right? What is the value of v? V is 5 multiplied cos. What is the value of theta? 35. Now we will calculate. If I even use the calculator, make sure that your calculator is in degree mode, okay, not in radian mode. If it is in degree mode, it will be displayed here D. If it is in radian mode, it will be displayed R. If it is not in degree mode, if it is in radian mode, you need to change it into degree mode. Okay, so you need to remember that when you are doing the examination. And 5 multiplied cos 35, which equals 4.095. So I will write 4.1 Newton is the x component, or it's means the component of this force along the x-axis. And what is the y component of this force? Y component means the part of this force acting along the y-axis, that we will represent by Vy. So the y component of this force, that is 5 multiplied sine the given angle is 35. So 5 multiplied sine 35, 2.867. So we will write 2.9 Newton. So this is how you need to calculate the x component and y component of a given vector using trigonometric equations. Now another example. So here a vector is given. This vector is along this direction. So when you take the angle should be always taken from the positive x-axis in a counterclockwise direction. So we need to take angle from positive x-axis like this in an anti-clockwise direction. So for example, this angle is about 130 degree. Okay, we will write 130 degree, and the value of this vector we will write this time we will write a velocity of 6 meter per second. So this is a velocity vector that is acting at an angle 130 degree from the positive x-axis. This is positive x-axis, right? And this is the negative x-axis. This is positive y-axis and this is the negative y-axis. So this velocity, a 6 meter per second velocity, that is acting at an angle 130 degree from the positive x-axis. So now we need to resolve the vector, means we need to calculate its x component and y component. So this is its x component. You can see the x component will be negative, right? So what is the equation to calculate x component? Vx, that is equal to 6 multiplied cos. X is cos, right? The angle making side, it is making an angle 130 degree with the x-axis. So the angle making side will be always cos. So for meanwhile, we can say the x-axis or the x component will be always cos. X component is cos, y component is sine. Remember like that. X is cos, y is sine. So cos 130, right? Cos 130. So 6 multiplied cos 130. 6 multiplied cos 130, which equals minus 3.86. So negative 3.86, right? Not 68. 3.86 meter per second. Why negative? Negative means it is a negative represent. It is acting to the along the negative x-axis or acting towards left side. Then what is the y component? So this is the y component, right? Y component of this velocity. How to calculate that? The y component of the velocity Vy, that is equal to 6 multiplied y is sine, right? Sine, what is the angle? 130. 4.59 meter per second. So you can see here this y component is acting along the positive y-axis, and when you calculate you are getting the positive value. Question number 2. Resolve a vector into orthogonal vectors in Cartesian coordinate system. So here we have a Cartesian coordinate system. We will draw a Cartesian coordinate system like this. The x-axis and the y-axis. So this question is from page number 117, and we have a vector here in this. For example, this vector is like this. So this is a vector, its value is not given, so we will represent this vector by letter V. The angle is also not given, so what is given is the values given here, values of the Cartesian coordinate, the x and y axis is given. We will write, for example, 1 2 3 4 5 6 like that, and here also we will write 1 2 3 4 5 6 1 2 3 4 5 6. Then we need to divide into x component and y component, or we need to find the x and y component of this vector. So I will write Vx for the x component. How to find Vx? From the tip of this vector. You know, every vector has a tail and a tip. This is the tail of the vector, the starting point of the vector, and this is the end point of that vector, that is called tip of the vector or head of the vector. So from its head we will draw a line here. Okay, so it's almost 6. Yeah, so we will write Vx, that is equal to 6. Then to find Vy from the head, like this, you draw to the y axis. What's the value you got for Vy? You got to 3, right? So now you got Vx, the x component value, and the y component value. So how to calculate this vector V? How to calculate the magnitude of this vector? You can calculate magnitude of that vector using Pythagorean theorem. So you know the value of this value, you know, right? Vx equal to 6 and Vy, that is equal to 3. So you can calculate the magnitude, because this x and y, that is 90 degree, right? 90 degree. So the x component and y component are perpendicular. So you can calculate the magnitude of this vector using Pythagorean theorem, that is Vx squared plus Vy squared. So what is the value of Vx? Vx is 6, so 6 squared plus 3 squared, which equals 6.7 is the value of this vector, the magnitude, okay, the magnitude of the vector. And say this is the angle theta this vector makes with the x-axis, that is the direction of the vector. So how to calculate the direction, or how to calculate that angle? You can use this equation to calculate the angle always. Theta equal to tan inverse opposite side over adjacent side, So which side is opposite to this angle theta? You can see here, this side is opposite, right? What is the value of this side? 3. So theta equal to tan inverse 3 divided by the adjacent side. What is the adjacent side? This side, 6. Its value is 6, right? 3 by 6. So theta equal to tan inverse 3 by 6, right? 3 by 6 is 0.5, right? So tan inverse 0.5. Theta equals shift to tan, okay, so you will get to tan inverse 3 divided by 6, that equals 26.6. So the value of the angle is 26.6 degree. So we can say this vector V makes an angle 26.6 degree from the x-axis, that is its direction. And what is the magnitude of this vector? Magnitude is 6.7. How did we calculate? First we calculated the x component from the values of the Cartesian coordinate system, and y component we calculated from the values of the coordinate system, and we used Pythagorean theorem to calculate its magnitude. So when we write this theta equal to tan inverse O by A to find the direction, you can write like this also, the same equation, okay, same equation that we can write theta equal to tan inverse y by x. The value in the y-axis divided by value in the x-axis means y component value divided by the x component value. So you can use You can remember this way or you can remember this way, which one is comfortable for you. That way you can remember how to calculate the or equation to calculate the angle. Question number 3 is to draw free body force diagram for an object moving on a horizontal surface involving friction. So for example, here we have a horizontal surface or a floor, and on this floor we have an object here, a wooden block, okay, a large wooden block. So we have a wooden block here. What are the forces acting on this wooden block? Can you say what are the forces that will be acting on this wooden block? There will be two forces acting, right? Two forces will be acting on this block. One will be its weight. Its weight, that we will write Fg, force of gravity, that is acting vertically downwards. And the second force will be the normal force, which is acting vertically upwards. So this force of gravity and normal force will be equal and opposite. You can see force of gravity is acting downward and normal force will be acting upward. Always these two forces will cancel each other. So these two forces, they are equal and opposite, so they balance each other. So this block is in equilibrium. It's like no force is acting on this block. Now what are you doing? You are pushing this block. Okay, you are pushing the block. It's a large wooden block, a large wooden box. You are pushing the block. When you push the block, what happens is then a friction will generate here. Even before the box start moving, there will be friction. When you start pushing, the friction starts. The friction acting, or friction will always act in the opposite direction, right? Friction will be always acting in the opposite direction, and the friction acting when the object is not moving, that friction is called static friction. Static friction. So what is static friction? Static friction is the friction when object is not moving. Friction acting when object is not moving. When object is not moving. So when the object is not moving, the friction acting, which is called static friction. So what are you doing? You are increasing your applied force. You are pushing harder. When you push harder, what happens is the static friction will also increase. Still you are pushing harder, means you are increasing your force, but static friction has a limit, means the maximum, it has a maximum value. And if the applied force, if you are pushing force that is greater than the maximum value, then what happens is the box will start moving. When the box start moving, still the friction will be acting, and that friction is called kinetic friction. When the object starts moving, the friction is called, or the frictional force acting when the object is moving, that is called kinetic friction. So what is the meaning of kinetic friction? Kinetic friction is acting when object is moving, when object is in motion. How much force is required to make an object start moving? So this block, to make the block start moving, the force required, the applied force required, or I will write the force needed, the force needed to make an object, move. The object was initially at rest, okay? So to make the object to move, we need to apply a force. That force will be equal to the maximum value of static friction. The force needed to make an object start move, or to make an object to move, is equal to maximum value of static friction. When the applied force is equal to the static friction, equal to the maximum value of the static friction, the object starts moving. And if the applied force is less than the maximum value of static friction, the object will not move. Now we will discuss how to apply Newton's second law in these situations. For example, here the block, this block has a mass of 20 kilogram. This block has a mass of 20 kilogram, and you are applying a force here. You are applying a force, that is, you are applying a 100 Newton force on this block, and there is a frictional force acting. The frictional force acting is 40 Newton. 40 Newton is the value of the frictional force. So how to calculate the acceleration of the block? To calculate the acceleration of the block, we have Newton's second law. What is Newton's second law? Newton's second law states that acceleration of an object is equal to net force acting on the object divided by mass of the object. F net, acceleration is equal to F net over m. What is A? A is the acceleration. What is F net? F net is the net force. It's also called resultant force. Net force or resultant force. It's called unbalanced force divided by mass. So F net is called net force, resultant force, unbalanced force, and m is the mass of the object. So acceleration, that is equal to net force divided by mass, that is Newton's second law. So what is the net force acting here? Here there are two forces acting, right? If forces are acting in the same direction, to calculate net force, add the forces. If forces are acting in the opposite direction, then to calculate net force, you need to subtract. You need to find the difference between the forces. So here you can see this 100 Newton and 40 Newton, they are acting in the opposite directions. So to find net force, you need to subtract 100 minus 40 divided by mass of the object. What's the mass of the object? Mass of this wooden block is 20 kilogram. So 100 minus 40 divided by 20, 100 minus 40 is 60 by 20, that is 3. Unit of acceleration is meter per second squared. And what is the direction of the acceleration? Direction of acceleration will be always along the direction of the net force. So here this 100 Newton force is greater than the 40 Newton force. So net force will be along the direction of the 100 Newton force, right? So the direction of net force will be along this direction. So the object will be moving, the block will be moving along that direction, and acceleration will be along this direction, right, to the right side. So the direction of acceleration will be always along the direction of the net force. Remember that. Question number 4. To define coefficient of friction and to differentiate between static friction and kinetic friction. Static friction and kinetic friction, that we have already discussed. What is friction? Friction is when one object is moving over the other. For example, when this object is moving over the other, there will be an opposing force between the two objects, between the two surfaces in contact. Okay, when this object is moving over the surface, so there will be an opposing force acting that will oppose the motion of the object. That force is called friction. So what is static friction? Static friction means now this object, I am applying a force. Okay, I am applying a force on this object, but it is not moving. I am applying a small force here, but the object is not moving. So what happens to my applied force? That applied force is balanced by the static friction. The applied force is cancelled by the static friction. So what is static friction? The friction acting when the object is not moving. You are applying the force, but the object is not moving. If there is no applied force, then static friction will be 0. Friction acting when the object is not moving, that is the static friction. Now I am applying a force that is greater than the maximum value of static friction the surface can apply. I am applying a greater force. Okay, so the object is start moving. When the object is moving, still the friction will be acting between the surfaces. That is called the kinetic friction. So what are the equations for static friction and kinetic friction? So for static friction we write like this: static friction So I will just write S to represent static friction. So force of friction S. So this is static friction will be always less than or equal to coefficient of static friction multiplied normal force. Static friction will be always less than or equal to coefficient of static friction multiplied normal force. So what is this coefficient of static friction multiplied normal force? That is the maximum value of static friction. So maximum static friction, maximum value of static friction, that is the force required to make an object to move, right? That is equal to coefficient of static friction multiplied normal force, coefficient of friction multiplied normal force. And what is the equation to calculate kinetic friction? Kinetic friction, I will just represent Fk, kinetic friction. The equation to calculate kinetic friction is, kinetic friction will be always equal to coefficient of kinetic friction, coefficient of kinetic friction multiplied normal force. So in both the equation you can see the frictional force is directly proportional to the normal force. For example, here we have a horizontal surface. For example, we have a table. On this table there is a book or a block, anything. So here what is its normal force? Normal force will be acting upward, right? Normal force is like the table will be pushing the block up, that is the normal force. And this is the Fg, right? The force of gravity, that is equal to mg, mass multiplied 9.8, the value of g, and this is the normal force. On a horizontal surface, the normal force will be always equal to mg, the force of gravity. For example, a horizontal table, an object is on the horizontal table. So what is the normal force? Normal force will be always equal to mg. On a flat surface, okay, a flat ground, and a block is on the ground. So what is the normal force acting? The normal force will be always equal to the weight of the object. So from this both the equation you can see that kinetic friction and static friction are directly proportional to normal force. So if we plot a graph, of friction against normal force, if we plot a graph of friction against normal force, that graph will be a straight line passing through the origin. Why the graph is straight line? Because friction is directly proportional to normal force according to this equation and this equation. You can see here static friction is directly proportional to normal force, kinetic friction is also directly proportional to normal force. So if we plot a graph of force, frictional force against normal force, the graph will be a straight line. And what is the slope of the graph? Slope is y by x, right? Slope is always equal to y by x. So what is on y axis? Y axis of this graph is friction, right? Friction. And what is on the x axis? X axis of this graph is normal force. So we have already discussed what is friction divided by normal force. Friction divided by normal force is coefficient of friction. So the slope of this graph, slope of friction against normal force graph will be equal to coefficient of friction. Slope is equal to coefficient of friction, and here I wrote like this because the coefficient of static friction, the value of the coefficient of static friction will be greater than the value of the coefficient of kinetic friction. So you can also say like this, static friction is greater than kinetic friction. Question number 5, for an object to be in equilibrium, the net force acting on the object must be 0. That also we get from Newton's second law. So what is the meaning of equilibrium? An object will be in equilibrium if net force acting on the object is 0, right? When net force is equal to 0, or we say net force, or we say that resultant force, both are same thing, different name. If an object is in equilibrium, resultant force is equal to 0, or we say when an object is in equilibrium, or condition for equilibrium is forces are balanced. Forces are balanced. So all these things are same, different usage. For example, we have two vectors here, two forces. A force A is acting on an object along this direction. For example, here is the object. A force is acting along this direction and another force is acting to this direction. Force A and force B, these are the two forces acting on that object. So what is the resultant? The resultant will be always from the starting to the end, right? The resultant will be from the tail of the first vector to the head of the second. So this is the resultant vector. So if I apply another force along this direction like this, so you can say this is the resultant, right, starting to the end, but opposite to the resultant we are applying a force. So here you can see this vector diagram is like a closed triangle. See the arrow, the vector diagram is going like this, right? It becomes a closed triangle. If the vector diagram is a closed triangle, it represents the forces are in equilibrium, means the net force is 0. So this force, the force in red color, which balances other two forces, right? This red color force that balances this force A and force B, and this force in red color is called equilibrant or equilibrant force, that we will represent by the letter E. So what is equilibrant? Equilibrant is equal and opposite to the resultant force. Equilibrant is a force which is equal and opposite to the resultant force. Or we can say equilibrant is a force which balances other forces acting on an object. So here this equilibrant force which balances the other two forces A and B acting on this object. So now the net force acting on the object is 0 and the object is in equilibrium. So what is equilibrant? Equilibrant. So equilibrant is equal to the resultant. Equilibrant is always equal to the resultant force, but the direction will be opposite. If the resultant is to the right side, then equilibrant to the left side. If the resultant is to along this direction, the equilibrant will be same in magnitude, but the direction will be just opposite of the resultant vector. Question number 6 is to describe the trajectory of a projectile motion. So you know that, right? What is a projectile motion? A projectile is any object that is thrown into the air, and in this diagram it is an angular projection, means we are throwing an object at an angle like this. So the object will be following a curved path, and the path of a projectile is called a trajectory, and the shape of this path is parabolic, right? So we can say a projectile follow a parabolic path. A projectile follow a parabolic path. So you are throwing a ball from here at an angle theta. So the ball will be following this parabolic path. So we know that on a projectile only one force is acting, that is force of gravity. The only force acting on a projectile is force of gravity, that will be acting vertically downward. So the acceleration will be always along the direction of the net force. So here only one force is acting, so the net force is force of gravity, so the acceleration will be always vertically downward on a projectile. So here there is no horizontal force. In horizontal direction, if I represent like this Fx, the force along the horizontal direction, that is 0. Ignore the air resistance. If you ignore the air resistance, there is no force in the horizontal direction. There is no force in the x direction. So what happens is the horizontal component of the velocity will be constant. So I will just draw this like this, some positions of this ball, yeah, like this. So here a projectile, you can see a projectile has both horizontal motion and vertical motion. See, the projectile has traveling in the horizontal direction, at the same time it is traveling in the vertical direction also. So a projectile always has both horizontal motion and vertical motion at the same time. So here there is no force in the horizontal direction, right? So as there is no force in the horizontal direction, the horizontal component of its velocity will be constant. It will be always constant. So you can see here the velocity is along this direction, right? Initially the velocity is along this direction, which means this object has a horizontal component of the velocity and a vertical component Vy, Vx and Vy. So a horizontal component that I will draw with this green color, horizontal component of the velocity Vx, that will be always constant. It will not change. Why it doesn't change? Because there is no force acting in the horizontal direction. So I will try to draw it with the same length. You must draw with the same length. At a maximum height also, the horizontal velocity will be same. The value of horizontal velocity will be same throughout the motion of this projectile. Whether I am drawing equal or not equal, it must be same. Then what happens to the vertical velocity? See here, acceleration is downward, right? The force of gravity is acting downward, means force of gravity is pulling the ball that you have thrown downward. So means force of gravity is pulling the object downward. So what happens is its vertical velocity, that we will represent by another color. We will use black color to represent the vertical velocity. So the vertical velocity will be decreasing. When it is going up, its vertical velocity will be continuously decreasing, and at a maximum height, the vertical component of the velocity that we will represent by Vy will be 0. At a maximum height, vertical velocity is 0, and you can see here the acceleration will be downward, right? Acceleration will be acting downward. Acceleration downward. See, there will be some questions like this. At a maximum height, the velocity and acceleration are perpendicular. At maximum height of a projectile motion, at maximum height of the path of a projectile, the acceleration is acting downward, and there will be only horizontal velocity, horizontal component of the velocity. Vertical component of the velocity will be 0 at a maximum height. So you can see the velocity and acceleration will be perpendicular at a maximum height. Then what happens after that? The object will be start moving down, right? It starts falling down. When it is falling down, the gravity is pulling it down, right? So its velocity will start increasing. The velocity will start increasing from 0. It starts increasing. So when it reach here, its velocity will be equal to its initial velocity. The length of the arrow is little bit different. So this we will write Vy. Vertical velocity is decreasing while moving up. While moving up, vertical velocity decreasing, vertical velocity decreasing. At a maximum height, vertical velocity becomes 0. Then when it starts falling down, vertical velocity start increasing, vertical velocity start increasing, vertical velocity increasing, right? So what is this? This one, it's not vertical velocity here, okay? Here just that represent acceleration, okay? That I just want to tell you that acceleration and velocity are perpendicular at maximum height. So this is all about the trajectory of a projectile motion. Now we are moving on to question number 7. I want to remind you that if you have not subscribed this channel, please subscribe it now, and we will continue. Question 7. Solve problems related to friction. This is question number 35 from page number 133 of your textbook. Dahlia, who has a mass of 45 kg. The name of the person may be different in the textbook, only the name will be different, everything else will be same. The question, the numbers, everything is same. So Dahlia, who has a mass of 45 kg, starts down a slide that is inclined at an angle of 45 degree with the horizontal. If the coefficient of kinetic friction between Dahlia's span and the slide is 0.25, what is her acceleration? So here we need to calculate the acceleration. So what is given in question? Dahlia, who has a mass, the mass of the girl that we will represent by the letter M, that is 45 kilogram. 45 kilogram. M is mass, okay, not meter. Mass is 45 kilogram. Starts down a slide that is inclined at an angle of 45 degree with the horizontal. So the theta is given, the angle is 45 degree from the horizontal. If the coefficient of friction between Dahlia's span and the slide is 0.25, coefficient of friction we will represent by mu, that is 0.25. What is the acceleration? We need to calculate the acceleration, or we need to calculate her acceleration. So we will draw the diagram here. It's an inclined plane, right, which makes an angle 45 degree from the horizontal. So Dahlia is here, and this angle is 45 degree. So this is the diagram. So her weight will be acting vertically downwards, right? Her weight will be acting vertically downwards, and normal force will be always act normal to the surface. So on an inclined plane, you can see how the normal force is acting. If it is a horizontal surface, normal force will act vertically upward, right? But this is not a horizontal surface, this is an inclined surface. For inclined surface, normal force will be acting like this, means normal force will always act normal to the surface. That is why it is called a normal force. It always act normal to the surface. Normal means it always act perpendicular to the surface. Normal means perpendicular. So this angle will be 90 degree. So here we need to calculate the acceleration, right? So we will just write what are the forces acting here. This is normal force, right? Normal force we will write Fn. So here we can divide this weight into two components. The weight that is parallel to this inclined surface and perpendicular to the inclined surface. So this is mg, right? Weight is mg. We will represent by mg. So mg we will divide into two components. One component that is parallel to this inclined plane, and the other component which is perpendicular to the inclined plane. So you can see here this component which is parallel to the inclined plane, that is mg sin theta, okay, that is the equation to calculate the parallel component, and the equation to calculate the perpendicular component is mg cos theta. You remember like this, mg sin theta and mg cos theta. So in this inclined plane, in every question in inclined plane, the normal force will be always equal to mg cos theta. Normal force will be always equal to mg cos theta. This normal force and mg cos theta, which is the perpendicular component of the weight, right? Mg cos theta is the perpendicular component of the weight, which will be always equal. Normal force and mg cos theta will be always equal. That we will write here like that. And there will be another force, one more force acting, that will be the force of friction will be acting in the backward direction. So Dahlia will be falling, or she will be sliding down along this direction. So frictional force will be acting. Frictional force always act opposite to the direction of motion. So direction of motion is to this side, so frictional force will be acting in the other side, in the opposite side. Friction always act opposite to the direction of motion. So here we need to calculate the acceleration, right? To calculate acceleration, first you must calculate the net force. The basic equation to calculate acceleration is equal to net force divided by mass of the object. Mass is given, but net force is not given. So we need to calculate net force. How to calculate net force? So here these two forces, you can see normal force and mg cos theta, they are equal and opposite, so they cancel each other. Normal force and mg cos theta, they balance each other. Why? They are equal in magnitude and opposite in direction, so they balance each other. So what are the two forces remaining? This mg sin theta and frictional force remaining. So you may ask, what about this mg? See, this mg we divided into 2, right? What is mg? Mg we already divided into mg sin theta and mg cos theta. So this mg is not there now. See, it is divided. We resolved into mg cos theta, its parallel component and perpendicular component. We wrote it separately. Okay. So there are these two, out of these two forces, this normal force and mg cos theta, they are equal and opposite, so they balance each other. Then what is remaining? Mg sin theta and the frictional force. So what is net force? Net force is, we will write, first we will calculate net force, right? Net force mg sin theta minus frictional force. Okay. So mg sin theta minus our frictional force, right? So we will write like this: mg sin theta, mg sin theta is frictional force given in the question? Given? No, frictional force is also not given. So we need to calculate friction also. What is the equation to calculate friction? Frictional force, that is equal to coefficient of friction multiplied normal force, right? So instead of friction we will write coefficient of friction multiplied normal force. So what is normal force? In an inclined plane, normal force will be always equal to mg cos theta. On a horizontal surface, what? On a horizontal surface, normal force is equal to mg, and on an inclined surface, normal force is equal to mg cos theta. So instead of writing normal force, we will write mg cos theta. So mg sin theta minus coefficient of friction multiplied mg cos theta. So we will get net force. What is m? M is 45, right? 45 multiplied g, 9.8 multiplied sin 45, right? Theta is 45 minus mu multiplied. What is the value of mu? So I will just write this in a bracket. Okay, minus mu multiplied, where is mu? Mu is 0.25, that is the value of the coefficient of friction multiplied mass m. M is 45, g again 9.8 multiplied cos 45. The net force, which is equal to 233.9 Newton, that is the value of the net force. But what do we need to calculate? We need to calculate the acceleration, right? So acceleration, that is equal to net force divided by mass. Net force is 233.9 Newton divided by mass. What's her mass? Her mass is 45 kilograms. So 5.2 meter per second squared is the value of the acceleration. Question number 8. To calculate friction, coefficient of friction, normal force. Problem 3 in page number 125 of your textbook. You push a 25 kilogram wooden box across a wooden floor at a constant speed of 1 meter per second. The coefficient of kinetic friction is 0.2. How large is the force that you exert on the box? So you are pushing a box, its mass is 25 kilogram. So first step of solving any question in physics is writing what is given in the question. So 25 kilogram, the mass of the box is given, so we wrote it. It's moving at a constant speed. So it's moving at a constant speed. If any object is moving at a constant speed, its acceleration will be 0. The coefficient of kinetic friction is given. Coefficient of kinetic friction mu is equal to 0.2. How large is the force that you exert on the box? So you need to calculate how much force you are applying on the block or on the box. So here is the box, and this box is on a floor. So we will draw the floor here, and you are applying a force. This is your applied force. You are applying a force, and frictional force is acting in the opposite direction. The force of friction is acting in the opposite direction. So here you can see you need to calculate how much is the applied force. So this is what you need to calculate, and you know that the object is moving, the box is moving at a constant speed. If the box is moving at a constant speed, what is the net force acting on the object? Net force equal to 0. Net force is 0 means constant speed means acceleration is 0. Acceleration 0 means net force is 0. Net force 0 means opposite forces are equal, right? Opposite forces are equal. So we can say the applied force that is equal to the opposite force. Which force is acting opposite to the applied force? The frictional force. So applied force is equal to friction. Is friction given in the question? If friction is given, you can directly write the answer, but friction is not given. You need to calculate friction. What's the equation to calculate friction? To calculate friction, the equation is coefficient of friction multiplied normal force. So this is the equation to calculate friction. What is the value of coefficient of friction? Coefficient of friction is 0.2. So 0.2 multiplied normal force. Normal force is not given, right? But the surface is horizontal surface. On a horizontal surface, normal force is always equal to the weight of the object, mg. So instead of normal force, we will write mg. So 0.2 multiplied m. What is m? Mass of the object 25 kilogram, right? 25. What's the value of g? 9.8. So 0.2 multiplied 25 multiplied 9.8, which equals 49. So 49 Newton. You are applying 49 Newton on the box. The next question, in calculating friction, Marwa exerts a 36 Newton horizontal force. I told you the name will be different in your textbook. Only the name will be different. Everything else will be same. Marwa exerts a 36 Newton horizontal force as she pulls a 52 Newton sled across a cement sidewalk. So how much force she is applying? She is exerting a force that is equal to, her applied force is 36 Newton, right? She is applying a 36 Newton force as she pulls a sled. What is the weight of the sled? See here, as she pulls 52 Newton sled, which means the weight of the sled is 52 Newton. So I will write mg, okay, mg, because weight is given, right? That is equal to 52 Newton. That is the value of the weight of the sled. And this also moving at a constant speed. If it is moving at a constant speed, acceleration is equal to 0. What is the coefficient of friction between the sidewalk and the metal sled runners? So we need to calculate the coefficient of friction. If the question is to calculate coefficient of friction, there is only one method. If the question is to calculate what? Calculate coefficient of friction. First, you must calculate friction. You must calculate friction first. After you calculate friction, then only you can calculate coefficient of friction in any situation. So if the question is to calculate coefficient of friction, first you must calculate friction. How to calculate friction? Friction will be always equal to, the frictional force will be always equal to applied force minus net force. Frictional force will be always equal to applied force minus net force. Net force is mass multiplied acceleration, right? So we will write like that. Frictional force is applied force minus net force. Net force is mass multiplied acceleration. So in this question, what is the value of the applied force? Applied force is 36 Newton. 36 Newton minus mass multiplied acceleration. Acceleration is 0, right? As acceleration is 0, this net force will be 0. So we got frictional force is equal to 36 Newton. Frictional force of friction, that is equal to 36 Newton. But the question is not to calculate friction, right? It is to calculate the coefficient of friction. You need to understand there is a difference. Coefficient of friction is not equal to friction, okay? If coefficient of friction is given in the question, you may think that yeah, friction is given. No, it's not friction. Friction and coefficient of friction are different. That you need to remember. So friction we calculated, right? So we have the equation friction is equal to coefficient of friction multiplied normal force, right? Friction is equal to coefficient of friction multiplied normal force, that is equal to 36 Newton. We calculated friction, right? We calculated friction, we got 36 Newton, so we substituted that in this equation. What is friction? Friction is coefficient of friction multiplied normal force. So you want to calculate the coefficient of friction, that is 36 Newton divided by what is the value of normal force. I told you if the surface is horizontal, normal force is equal to weight. Normal force is equal to mg, the weight of the sled, that is given here, right? The weight is given 52 Newton. So 36 divided by 52, how much? Will it be greater than 1 or less than 1? 36 divided by 52, the answer is 0.69. 0.69. I want to tell you two things about this answer. You can see here, one, the answer is less than 1, right? The value is less than 1. The value of coefficient of friction will be always less than 1. If you get any answer that is greater than 1, which means your answer is not correct, you need to check your calculation again. So when you calculate coefficient of friction, you will always get a value that is less than 1. And what about the unit of coefficient of friction? Coefficient of friction has no unit. Why? Because coefficient of friction is a ratio of force over force, correct? Frictional force divided by normal force. So Newton and Newton will be cancelled, so coefficient of friction has no unit. The next question in this, Hassan is dragging a box full of books from his office to his car. The box and books together have combined weight of 134 Newton. So weight is given in this question. I will write mg because that is weight, right? 134 Newton, the weight is given. If the coefficient of static friction between the pavement and the box is 0.55, so the coefficient of friction is 0.55, no unit. How hard must Hassan push horizontally on the box in order to start it moving? So you need to calculate how much force you need to apply to make an object move, to make that box of book move. We have discussed the force required to make an object start moving, that is called static friction, or that is equal to static friction. So I will write here applied force to make an object moving, that is equal to static friction. To calculate friction, whether it is static friction or kinetic friction, there is only one equation. Friction is coefficient of friction multiplied normal force. Coefficient of friction multiplied normal force. It's very easy because coefficient of friction is given here 0.55 multiplied normal force also given here, right? Normal force is always equal to mg for a horizontal surface. So 134, 0.55 multiplied 134, which equals 0.55 multiplied 134, which equals 73.7. 73.7. What's the unit? Newton, right?